Hello, everyone. Welcome back to my factoring series. This is part 4, and as I described in the last video, this is where I give you guys the keys to the castle. This is where I give you sort of what I feel is a foolproof method to be able to factor pretty much any quadratic. So up until now, we've been dealing with a in ax squared plus bx plus c. We've been dealing with a being only equal to +1. And that's let us simplify things down to the point where we can reasonably do like a guess and check method, right? We can kind of just logic our way through, hey, what does this probably factor into based on what we see here and based on the fact we know how we'd have to FOIL things out to get to this point. So we're not doing that anymore. A is now permitted to be any whole number. And I want to make that clear that for our purposes in this video, I'm not going to be dealing with fractions. I'm not going to be dealing with decimals. Generally speaking, if you have fractions or decimals in a quadratic, you wouldn't be factoring anyways. Sometimes your teacher might throw one in there to be a bit of a curveball. But usually if you see fractions or decimals, you're expected instead to use some other method to solve a quadratic equation. We're not quite there yet. We're just factoring, but you're probably expected to do something like use the quadratic formula. So because of that, we're just going to use whole numbers. They can be negative, right? I'm not going to pull punches there, but I'm not going to have decimals. I'm not going to have fractions, just to keep things kind of nice and concise. Otherwise, this conversation takes a lot longer. So let's go ahead and start with, much like our last time together, is we're going to go backwards. So rather than factoring, I want to show you generally how we get to this place to begin with. So we're going to start with two binomials that we're then going to FOIL together. So I have 3x plus 10, and I have 4x minus 7. So I'm going to FOIL these out. And so I have 3x times 4x is 12x squared. I have 3x times -7, which is -21x. I have 10 times 4x, which is a positive 40x, and I have positive 10 times -7, which is -70. I will go ahead and collect my like terms, which are these two middle guys, and this is going to be 12x squared plus 19. Sorry about that. 19 is just a funny number. I always get stuck there. So 12x squared plus 19x minus 70. Okay. So let's observe a few things. I do want to say, like I just mentioned, 19 is a very strange number. I'm not sure I can really do anything with the knowledge that that middle term, our B term, is positive 19. I am scratching my head there. However, these two numbers, the 12 in front of the x squared term and the -70 as our C term, these tell me some things. So if I look first at the 12x squared, this tells me that the binomial foiling that got me to this point, that our two first terms, are like x terms, had to multiply together to be 12. So the coefficients of them had to multiply to be 12. So for example, 12x and x could be a possible, kind of place where we got these from. We could have also had something like 2x and 6x. We could have had 3x and 4x. And once again, we'll stop here because I'm not going to include fractions or decimals. So we know that we had one of these three things occur, right? The binomials that this quadratic factors into has to look something like this. Has to be either 12x and x, 2x and 6x, 3x and 4x. We of course know, because we already kind of did this backwards, that it's 3x and 4x. But in general, we would not know that. In addition, we know that due to this negative 70 here, that is ugly looking though. Due to this negative 70 here, we can also assume some things about the last two terms. So like the second term in each binomial. So for example, I could say something like it's negative 70 and plus 1. We could also say it's plus 70 and negative 1. We know that it has to multiply together to give us a negative 70 rather than just a positive 70. But I'm not going to write everything twice. Just know that the negative and positive signs could be swapped in each of these. So we could have instead something like 35, negative 35 and plus 2. That gives us negative 70 as well. There's no 3, there's no 4, there's a 5. So negative 14 plus 5. That is a possible scenario. And lastly, I believe negative 10 and positive 7 do also multiply to give us a negative 70. And once again, there's not just 4 of these, there's 8 of these. There's one for each of these where the sign is flipped. So keep that in mind. So if you didn't have any other method and you just had to guess and check your way through, there are a lot of different combinations because you would have to choose the correct pair over here. Right? Is it 12x and x? Is it 2x and 6x? Is it 3x and 4x? And pair it with the correct one of these. And remember, there's actually 8 of these. There isn't just 4 because there's one where the signs are flipped. We did this backwards, so we know that it's this, and then it's this with the signs flipped. But how long would it take you to figure that out on your homework, on a quiz, on a test? Would it be reasonable to actually do that on a test, considering the time constraints you have? Maybe, maybe not. Now, for some of you who do plan on going forward in STEM, you will eventually get to the point where you can kind of do this in your head even pretty quickly, but you're going to have to do like, maybe thousands of these factoring problems before you get to that point. So we're not quite there yet. We're going to come up with a better method. And before we do that, I kind of want to observe the method of foiling. So what I want you to notice is we have this intermediate step. We go from here to here, and then from here to here. So when we factor, we are going to choose to go backwards. So we're going to have a step where we take our quadratic, so our 3 terms, and we're going to expand it into 4 terms. So we're going to end up splitting the middle into 2 separate, our b goes into 2 separate coefficients, for lack of a better phrase, because clearly my words are escaping me. So we want to consider that as we go forward. All right. So this time, we're not going backwards. We're actually going to solve one of these. All right, what do I have? All right, so I've got, let's see. I put 19 in so many of these. I hate that number. All right. Got 10x squared minus 19x plus 6. So here is what we are going to do first. Little sidebar. We're going to take our a term and we're going to multiply it by our c, so just the coefficients. And here that gives us 60. And then we're also going to look at just our b term, which is negative 19. I want to find 2 numbers that multiply to be 60 while also adding to be negative 19. So a couple of things here. 60 is positive. Negative 19, obviously negative. So if I'm multiplying to get a positive number, but at the same time, those same numbers are adding to give me a negative number, then they both must be negative. And for 60, I think I know what it is. I think it's negative 4 and negative 15. So I believe that, yeah, if we take negative 4 and negative 15, we multiply them together, we get 60. We add them together, we get negative 19. So here's what I'm going to do. I am going to split my b term of my quadratic into those two things. So negative 19 is instead going to become negative 4x minus 15x. The order does not matter. If you put negative 15x first, this still works. You're fine. So notice that I haven't actually done any, like there's no cryptic voodoo magic going on here. I can rewrite negative 19 as negative 4 minus 15, right? There's nothing wrong with that. I haven't actually changed the value of these terms. I've just decided to split them into two different denominations rather than having them as one single number. So from here, it's not exactly obvious what we should do. However, I'm going to go ahead and say, let's split this up. I'm going to go ahead and look at the front half and the back half as if they're two separate two-term binomials. So I'm going to look at just 10x squared minus 4 by itself, and I'm going to look at just negative 15x plus 6 by itself. I'm not going to do anything else. So I should probably also give myself a little bit more room. I do not use the space on this infinite whiteboard effectively. Okay, so 10x squared minus 4x. I'm going to shortcut this a little bit, but if you go back to one of our previous videos, I believe it is lesson 2, we kind of talk about finding the common factors and taking them out of any two-term binomial. So I think a 2 can come out, and I see that they both have an x in them as well. So what is left is 5x minus 2. So if I take a 2x out of 10x squared, I'm left with 5x. If I take a 2x out of 4x, I'm left with just 2. Great. Second piece here. I'm going to go ahead and take out, I'm going to put a plus sign in between. I'm going to go ahead and take out, it looks like what, 3? 3, so if I take a 3 out of 15 or negative 15x, I'm left with negative 5x. If I take a 3 out of positive 6, I'm left with a positive 2. And I want you to notice that the parentheses here are very, very similar. They're off by a negative sign. So one of them is the opposite of the other. This is not quite what we want. At this stage in this method, what we want is we want the two parentheses to be exactly identical. Exactly identical. So let's see here. For the second one, instead of taking out just 3, I'm going to take out a negative 3, which allows me to switch the signs of everything inside. Okay, cool. So now I notice that both parentheses are 5x minus 2. Great, wonderful. So looking at this, if I look at each of these as one single term, I have a term here and I have a term here, I notice that they both have one thing in common. They have the 5x minus 2 parentheses in common. So I'm going to factor out 5x minus 2. I'm going to grab the common factor between both of them and factor it out. And the thing I'm left with inside is 2x minus 3. So that does it. That is our factor method. So let's do a little review. The crux to this method is this part right here. We're finding two numbers that multiply to be a times c while simultaneously adding to be b. Those two numbers split the middle term. They'll always split the b term into two separate pieces. And from there, you do what we call factor by grouping, where we say, I'm going to look at just this half, and then I'm going to look at just this half. Once we get to that point, we should see that we have identical parentheses. If we don't, that's a good sign we've done something wrong and that we should maybe backtrack. But if we have the two pairs of identical parentheses, we're basically done. We just need to factor the parentheses out, and then we're left with the other stuff being inside its own pair of parentheses. I did a little trick where I factored out a negative sign as well to get rid of everything that was inside. That might be necessary. I might not. Do I have anything? No. Okay, so I should probably really quickly state something else. So like, let's say, for example, we'll get there. We'll get there in a quick second. Don't worry about it. Let me see here. Yeah, let's say we have 3x squared plus 2x plus 1. And we want to go ahead and factor this in the same way. So a times c is, let's see here, 3, b is 2. Oh, excuse me. Yeah, this is one I just conjured up out of my head because I realized there's something we need to go over that I didn't put in my notes. Okay, so let's see. I went ahead and changed that to be 4. So we have a times c is 3 and b is 4. So the two numbers are 1 and 3. So I'm going to go ahead and split my middle term into 1x and 3x. So let's see, I have that, and then I have plus x, and then plus 3x plus 1. I want to go ahead and factor. So in the first half, I see that just x is in common. And then here's what I wanted to get at is, notice in the second half that there is nothing really in common, right? 3x and 1, there's nothing really you can pull out. In this case, we say just pull out a positive 1. You can also pull out a negative 1 if it's appropriate. In this case, it's not. It's just we need a positive 1. And sometimes you need to do this little trick here, which apparently I didn't put into any of my examples, but definitely important to show you that. And of course, this will factor into 3x plus 1, and then just x plus 1. So keep that in mind, is that sometimes you may need to factor out a positive 1 or a negative 1. The mistake that students will often make is say, oh, there's nothing in common. I guess I factor out a 0. No, it's not 0. It is 1, or, if it needs to be, it's negative 1. So that's something I want you to keep in mind. Okay, so let's do a couple more examples. What else do I have here in my bag of goodies? I have like a lot of stuff prepared. I don't think we're going to get to all of it, but there is definitely some other stuff we should be doing. So let's see, negative 2x squared minus 12x minus 18. So this is a pretty interesting one, just due to the fact that everything is negative. So there are ways to deal with that. What you may also notice is everything is a factor, or I'm sorry, not a factor, but a multiple of 2. And so I want to remind you of something I said in a previous video, is that you should always, always, always be thinking about common factors before applying any other factoring method. So common factors should always come first. I notice I could potentially pull a negative 2 out of all 3 of my terms, my a, my b, and my c. So if I were to do that, if I were to pull out a negative 2, I'm left with x squared plus 6x plus 9. Which is a lot simpler. This is actually more akin to what we were doing last time around, where I can just say, okay, what is my C term? My C term is 9. What is my B term? My B term is 6. And what two numbers give me, multiply to be 9, but add to be 6, 3 and 3. Okay, cool. Notice this is still more or less the same method. It's just because A is 1, we get to disregard it. Okay, so 3 and 3. I know then this factors down into x plus 3 and x plus 3, and the negative 2 comes along with. Now, you're probably wondering, hey, Eric, what happened to that middle step where you split apart the middle term? And, what gives? What gives? You told us we needed to do that. Why is that step not here? So if your A term is just 1, you can assume that these two numbers that you found will be the factored forms. So you get to skip the entire middle step if A is equal to 1. Now, if you're not comfortable with that, if you would prefer to do every step every time, just, to get it into your head, to kind of put it in there, then by all means, please do so. But I want to, be considerate of, what sort of time constraints you guys will be under, because I know many of you will be taking tests, and having a little shortcut method might help you get a couple extra questions on your test. I've seen that, a fair amount of time where a student who maybe wasn't finishing their test beforehand, you give them a little shortcut method like this, and it helps them, get those last 2 to 3 questions on the test that they otherwise had to leave blank. So something you can keep in mind is if there is just a 1 here for your A term, that you get to skip the splitting of your middle term. You can skip that step and just plop your 2 numbers straight into the final product. All right, so that's another important lesson. Hope you guys are taking notes. You don't need to. You can just watch this video again. All right, what else do I got? Ew. That's gross. All right, one more. 6x squared plus 34x plus 40. I feel like my handwriting is getting worse over time. It's not how that's supposed to work. All right, looking at this guy. So my use of space is not the best. This guy, we have the same issue where we should look at this and notice, first of all, that there is a common factor between all 3 of our terms. We can take a 2 out of each of our terms. So if I take out a 2, I'm left with 3x squared. I'm left with 17x, and I'm left with 20. Now, unlike the last time, we still have an A term that is not equal to 1, even after doing this common factor thing. So we still have to do our long method of, okay, what's A times C? Looks like A times C is 60, 3 times 20. And our B term is 17. I also notice everything's positive. So we're going to have 2 positive numbers. So 2 positive numbers that when we multiply together, oh, you know what, I see it. 5 and 12. 5 times 12 is 60. 5 plus 12 is 17. Great. Fantastic. So I can split up my middle term to 3x squared plus 5x. Once again, it doesn't matter if I put the 5 or the 12 first. It will work either way. Okay, cool. So I'm kind of, ignoring the 2. The 2 is not going to be a part of this factoring method. Let's worry about what's inside these parentheses. I'm going to split this term here. I'm going to look over here. And let's see. I think the only thing I can pull out of these first 2 is an x, because 3 and 5 don't have common factors between them. The other guy, though, these last 2 terms, I can pull out a 4, it looks like. So I can pull a 4 out, a positive 4, and what's left is 3x plus 5, which is great because, once again, our 2 parentheses have the same thing inside of them. which is good news. It tells us that we have done everything correctly up to this point. So we have our 2. We're not going to forget about the 2 because if we do, it's wrong. And that leaves us with 3x plus 5 and x plus 4. Great. Hope you guys are following up to this point. Let's see. I've got one more. Got one more for us. It's not that ugly. It's not that bad. It's not that bad. We'll be fine. Man, I really like the number 12, apparently. 12x squared plus 39x minus 36. Okay, cool. This also has a common factor in it that I can pull out of all 3. I don't know if you guys can see it, but it looks like I can pull a 3 out. So I've got 3 times 4x squared plus 13x minus 12. Okay. So let's see, 4 times 12 for our a times c term, that is 48. And then, oh, I'm sorry, negative 48. 12 is negative. So we have 2 numbers that multiply to give us a negative number, but add to give us a positive number. Not just a positive number, but a reasonably large positive number under the circumstances. So we know that one of our numbers is positive, one is negative, because otherwise, how are we going to multiply to get negative 48? We know that the positive one is bigger by 13. (16 and 3), right? So negative 3, positive 16. 32. Well, yep. Okay. All right. So 13. And guys, I know I did that fairly quickly, but you can go ahead and, if you are struggling to figure out what your 2 numbers are, what I like to do is I list all the different ways I could get 48. So 1 times 48, 2 times 24, 3 times 16, 4 times 12. I don't think there's a 5 times something. 6 times 8, right? 6 times 8, yeah. And if you have all of your possible different pairs of numbers lined up, it'll be easier to spot which one you need in the lineup. Now, obviously, as numbers get insanely large, that gets more and more difficult, but it's still, in my opinion, better than guess and check. All right, so like I was saying, so we are splitting up our middle term into negative 3x and positive 16x. Order not important. We're going to go ahead and split our middle term. The first 2, I only see the x coming out. Once again, 4 and 3. Not really much what I can do with those 2. The second pair, I clearly see that they have a 4 in common with each other. So let's see, 4x minus 3. I once again see that the 2 parentheses are equivalent. They have the same thing. So I've done everything correctly up to this point. So I will make sure that I factor out the common term of 4x minus 3, leaving x plus 4. And of course, I want to make sure I bring the 3 along for the ride. And that is my final answer. Okay, so I think I've demonstrated this method enough. I have shortcutted a few things. So for example, the factoring of the pairs, right? The factoring of our individual binomial halves, I've shortcutted a little bit. So recall that there is a more expanded way to figure out what is in common and how you would factor out what is in common in part 2 of this series. But hopefully, you looked at that video not too long ago, and so you're not confused as to how I'm going from this step to this step. So this is the general factoring method that I use, that I teach to all my students. This will get you what you want 99% of the time. There are certain like special forms that we will be covering in the final part of this series that are just the kind of oddballs. And it's important to go over those individually. You can actually solve a lot of them with this method, but I don't recommend it. This method is like more clunky than it needs to be for those special methods, because the special methods have like these nice shortcuts. So I'll be showing that to you in the next video. But for now, hopefully you'll be able to go through the problem set that I've prepared for you regarding these general factoring quadratics. And with that being said, best of luck. I'll see you in the next video.